All right, we're still reviewing chemistry here in molecular and cellular biology, and we're going to look in this very short recording at the chemical reaction basics. I just need people to be oriented so that when I put chemical reactions up, they know what I'm talking about. And so some basic terminology that we need: chemical reaction, making and breaking chemical bonds. All right, we're moving stuff around. That is chemistry, right? So we're going to talk about reactants. These are the starting molecules of chemical reaction, and then the products are the result at the end of that chemical reaction. Right? And so these are terms that I'm just going to use. You need to be familiar with them. So if we look at that, again, we can look at the formation of water from molecular hydrogen and molecular oxygen. We see the product over here is water. Our reactants are over here, and the reaction arrow indicates we're moving from left to right. Right? Now, we can talk about right to left as well. You can run that reaction backwards, but it takes some different concentrations and some different energy. But the whole point of this particular talk is I really want to drive that idea home, that reactions, almost all reactions, should have a double-headed arrow. All right. Now, what kinds of chemical reactions? You can have A and B get together. You can have decomposition reactions, synthesis versus decomposition, single replacement, double replacement. You'll go over all the specifics in your chemistry class or reviewed from a chemistry class. We're not going to worry about that too much, other than the fact that you want to realize that you can have all different kinds of arrangements. So you can break things down or build them up. It's all chemical reaction. All right. Now, as we look at these chemical reactions, again, I want you to be familiar with the chemical reactants on this side and the products, as well as the coefficients. The coefficients are going to allow you in chemistry to balance reactions. In this case, they're going to tell you how many, in this case, carbons you've got going on here, right? So keep that in mind as we move into our final kind of idea here, which is equilibrium. So not every intro chemistry class is going to delve into this in any great detail, but I want you to understand it, and we're going to review it as we go into water itself and buffers, and then certainly as we go into metabolism. This idea of equilibrium is very, very important. So every reaction, as we study that reaction, you can calculate what's called an equilibrium constant for it, and that's Kc. Right? And there's no need to get scared when you see all the symbols. We just have to define the symbols and move forward, right? So if we look at a general reaction where the little letters are our coefficients, how much A do we have, how much B do we have, C or D? So A plus B are becoming C and D. All right. So our reactants are becoming the products. Okay. Now, what we can do is when we calculate that, we can plug it all into this formula, and we get a number. And that number then represents a fact about that reaction, about how those things get together. Now, the key here is to think about the idea that most biological reactions have an equilibrium constant that's going to push everything to the right. Okay, and that's the language that we use. We say, oh, here are the reactants on the left and the products on the right, and we're moving from left to right. So the equilibrium of this reaction lies far to the right, meaning that if I mix these two together under the right conditions for the reaction to occur, I'm going to get mostly this on the other end. Like that's what's I'm going to have, right? And that's not always going to be the case, but a lot of biological reactions the equilibrium lies far to the right, right? Now, the whole idea of the equilibrium constant, though, is that if I move these concentrations around, right? If I give you a whole lot of product, there are times where I can push that reaction back to make what were the original reactants. Right? And that's going to be something to think about, especially as we move towards regulating biological reactions. So the fact that we can generate a Kc kind of indicates that concentrations are going to dictate which direction that reaction is going. And again, most chemical reactions you really want to think about with a double-headed arrow as opposed to that single-headed arrow. Right? So do think about this. This is going to be important, and we'll address it as we go through the quarter.